If you're responding to an incident response activity on a cloud account, you probably want to hear this. I have Rich Mogul, who works for Securasys and also runs the popular Cloud Slaw, or a cloud security lab a week. He'll be walking us through how to do an incident analysis to make the best calls for your incident. Now, he's run a few classes at Black Hat as well, so I could not think of a better person to talk you through this. Now, Rich created this video as part of the Admin Cloud Security, so you can also find this video on admin.cloudsecuritypodcast.tv. But for now, let's get into the video.
It's time for my favorite holiday recipe for incident response. Hey everyone, my name is Rich Mogul and I write over at Securasys and I publish Cloud Security Lab a Week, or Cloud Slaw, which is a free weekly newsletter with cloud security training. Now, I also do some bigger training classes, and one of those is on cloud incident response that I've taught for years at Black Hat with Will Bankson. And in that class, we go in depth on building detections, different kinds of analysis techniques. What I want to do today is take a little piece of that class, and which is, I think, one of the more important parts of it, break it down into a video and walk you guys through how to actually perform incident analysis. Now, this is a little bit of a different approach, and I want to give you a little bit of background about where this comes from. So I've got these crazy hobbies. I'm a paramedic. I've actually been professionally a paramedic. These days, it's kind of like a little bit of a side gig for me. And about a year ago, I got my private pilot's license. And in both of those, we use a lot of memory aids because they're very checklist-driven and process-driven professions. As a paramedic, you guys probably actually know ABCs, airway, breathing, and circulation. And we have more advanced ones like OPQRST, which is how you evaluate chest pain, onset, provocation, quality, radiation. Anyway, nobody cares. Then over on the flying side, we have really similar ones, like the checklist we use when we're getting ready to land, different checklists for just a whole bunches of like preparing for flights and those sorts of things. These memory aids are called mnemonics. You've seen them before. You take an acronym like ABC and you use it to make sure that you don't miss anything. And I think we're actually bad in the information security industry about using mnemonics for many of our procedurally oriented things. And that's why I came up with a mnemonic for cloud incident response, and it's called Recipe Picks. Now, this is available at a blog post over at securasys.com, and I'll pop it up on the screen now because I actually did a cool little infographic on it. Thank you, Canva. The idea behind Recipe Picks is this is my rapid cloud incident analysis guidelines. So these are the information I want to gather right away when there's a cloud incident in part of my investigation. And the reality is this is going to tell me like 90% of what I need to know about most of the incidents that I deal with. What we're going to do today is I'm actually going to run in my training environment an actual live attack, and I'm going to walk through the Recipe Picks mnemonic and show you how to analyze an incident and give you a lot of queries and hints that you can use yourself. A little bit of background. This is the same environment we use for our training classes. It's an automated target range, so I can stand up accounts, set them up to be targets for particular kinds of attacks, and then run automated attacks against them. Really great way to simulate the entire process from start to finish. And in this case, I've already run that attack. So let's go ahead and start with our incident detection. Now, in my case here, I use a platform that we have over at work called Firemon Cloud Defense. It's actually, we built it, we sell it. That's irrelevant for this class. This is wired in with a bunch of threat detectors, and one of them is to detect any time a snapshot is publicly accessible. This is a very common exfiltration technique to either make this publicly accessible or share a snapshot with an account that is under the attacker's control. So my threat detector is all configured to detect the API call when something is made public or when it's shared with an account that's unknown, but we use the public one today. And I want to grab that snapshot ID, and I'm going to just copy that to my clipboard. Then I'm going to go and look at my mnemonic, and this is what's going to remind me or guide me through the response process. Now, how am I going to do this, and where am I going to get started? I'm going to show you really quick what the target environment is set up like, and I'm going to do a couple little configuration things so that we can actually run our queries. I'm logged into the account here, just double checking. Yep, I'm in my incident response demo account. And the first thing I need to do is go into CloudTrail and make sure that CloudTrail is enabled. CloudTrail, if you're not familiar, if you're new to AWS, is the tool that collects all of the management plane API calls. Now, it's always available in your environment. You get like 90 days, but we set up a trail that's saving to an Amazon S3 bucket. And by saving it to that bucket, that gives us stored logs that we can run queries against. And in this case, I'm sharing to that particular S3 bucket. You don't really need to know that. If I want to actually look at live what's going on, I can go into the event history. And I can even run searches on the event history. Let's see, I haven't done this in a little while, but you can actually see all of the events in this particular account here. And I could run a query, say, on the resource name. Oops, and we'll pop it in, and we'll see if something pops up. And I get my query results on the resource. Now, I'm going to not run my analysis out of here. This is a really terrible place to run your analysis out of your queries and such. But you could actually see already, I can see the create snapshot API call and who made that API call. But instead, I'm going to show you how to do this with queries that are like SQL queries. A little bit more professional way to approach this problem. Now, before we can do that, we have to set it up. So we have those log files being saved, but we want to go ahead and enable it for Amazon Athena. Now, you can have your own SIM, your own query tools, whatever you want, your own log analysis. This just works really well for myself in my training environments, which is one of the big reasons I use Athena. Athena is a tool that allows me to run queries directly on data stored in different places, including Amazon S3. So even though these are files that are JSON formatted and it's not in a relational database, I can still run SQL-like queries on the data stored in those files stored in S3. That's what Athena gives me. But to make it work, I have to create something called an Athena table. So Athena needs to know what the JSON data should look like so it can create its table that I can run my queries on. Now, fortunately, in the console, it's great. It's got that little button, create Athena table. I'm going to pick my bucket where I want to store this or where I'm pulling my data from, look through and click create table. And that's all done. Now that data has already been stored in S3 since I set up this environment. And you're actually going to see some interesting things as we get into it. But the Athena table is what we need to create to be able to do our queries. With that set, let's go over into Athena and we're going to start our recipe picks, our incident analysis process. So I'll go to services and Athena, and you can tell that I've been in here already. So I'm going to go start off with my incident. So the first thing I have is what is the resource, the current configuration state? And I'm going to open up a second window. I'm going to leave that Athena window open because we'll come back to it. But I have a snapshot ID and I want to get a look at that snapshot. This is the first thing I like to do in all of my incidents is, especially if I'm dealing with a resource that's been exposed, what am I working with? What's that current configuration? Now, if you have a cloud security posture management tool or something similar, you can go ahead and use that to actually look at the configuration of your current resource. And in my environment here, I've got a bunch of other stuff because this is a persistent environment that I've got set up to look like a real actual account that you might use in an organization. So I've got my snapshot here and we'll go ahead and click on it. And that one is pulled directly from my threat detector. Remember, I copied out that ID. And I can see a few things here. So here's my snapshot. If I actually look at the snapshot settings, I can look down here and I see that that is public. And the thing that I care about is where did that snapshot come from? All snapshots are basically backups of storage volumes. So I'm going to open up that storage volume in another tab so I can see what's going on here with this particular storage volume. I can see that, okay, here's a storage volume. It's 8 gigs in size and it's attached to an instance. Now, this is the part that I care about because now I'm honing in on what data is possibly exposed because I'm looking at the actual source of what that snapshot from, and that is from an instance. So I'm going to flick over here to look at that instance, and not a lot of information here, but if I click on the instance name there, I can get a better idea. So I can see, well, it's got an IAM role associated with it. That's something that could be an issue. Maybe we'll get back to that. And I can see what image it was based off of. I'm going to go to tags. Let's see if it's got a name. Okay, so it doesn't have a name tag or anything else, but I can see right here, and again, this comes from just knowing the environment a little bit, is that this is in an auto scale group. And so that's not uncommon there. You can see the auto scale group name. So already I've got a little bit of information. I know based on the name. So this one is good. It really helps my response when people name things appropriately, that this snapshot that was made public comes from a running instance in an autoscale group. And that instance is in the group that says my website dev. So it came from my development website. And that's what's been shared publicly. Now, I could go ask somebody, kick off another process to figure out what's exposed, and we'll actually get to that at the end. This is enough for me to go, all right, I'm going to go back to my checklist. I'm going to knock off that R because I know the current configuration state. I know a little bit about where it came from. So I know it came from a website server, and I know somebody took a snapshot and made that snapshot public. Now I need to start running things down into the next steps. Remember, this is your triage. This is trying to figure things out as quickly as possible. It's not trying to know everything that occurred. We're going to get there. Going down to the events, API call on that resource. I want to know all the API calls on that resource because that's going to give me the history of that resource, probably going to tell me what triggered this individual incident. And so that's where this query comes into play. And this actually came from that blog post. So I have all the queries here. Now, a couple of things are I have to put in the right table name and I have to make sure I put in the snapshot ID into the right places. The table name, it's right over here on the side here. So you can see tables. This is the table that we're working with. And I just copy my name out of there. If you actually want to see the table structure, you can hit the plus. It's going to show you everything. So this is my table name from the last time I ran this. And I'm going to go and paste in my table name. And then I have to have the correct snapshot ID. And you can see I was running some query on AMIs. Let's go ahead and we'll delete that out. And I got to get my snapshot ID again. So let me pull that from this page. So I'm going to copy that ID. And I'm going to explain what this is in just a moment after I get this pasted in there. And then I'll walk you through the query and some of the key points. Here's what we have going on. As you can see, it looks just like SQL if you've ever written SQL queries. So we're going to select. These are the things that I'm going to pull. So I'm going to get the user identity, the request parameters, which was the actual API call that was made, the name of the event, the source IP address, when it occurred. And to be honest, I don't even know why I leave that in because the resources field almost has nothing in it. It only works with a couple of services. It's a very weird thing about AWS I don't want to get into today. Then, and remember, our objective is I want every API call that was made on that snapshot. So there's two places where that ID is going to show up. One is in the request parameters. The request parameters is when you make the API call, what are you asking for? And in the request, if I want to make a change to the snapshot, I'm going to specify the snapshot ID. Now, what are these percentage signs? Those are wildcards. So that's just like an asterisk anywhere else. And I put a wildcard at the front and then at the back. Because for my purposes, I want every API call where that snapshot ID shows up at all. Like I'm not really filtering anything down. I want anything and everything. So I can just say anything before, anything after. If that snapshot ID is anywhere in request parameters, I care about it. Then the other part is the response elements, which is what AWS returns. So an example of what this means is if I made an API call that said, create a snapshot of this storage volume, which is one of the ones we're going to see here. I don't know the snapshot ID when I make that. So the snapshot ID is not in the request. Amazon gives me the snapshot ID in the response. And if I want the full picture of everything that's going on, I have to make sure that I have both the request parameters and the response elements in my query. And that should find everywhere any API call related to that resource. All right, zooming out here and let's click run. Fingers crossed there's no syntax errors. Great. So I have the correct table, the request parameters, the response elements, and this is everything associated with that snapshot. And look at this. There's a lot going on here. But let's break this down. And the easiest one to look for right now, there's two things I'm going to focus on and I'll come back to. One is who made the API call. And I know I've got a backup manager user. And then I have these other things. I know what these are. These are specific in my environment. That's my monitoring tool. So my threat detection tool, that cloud defense tool, looks in real time. So it's going to be making a bunch of API calls. The ones I care about, I could filter those out of my results if I was using a different kind of tool. The other one is ones by rmogul. That's me. And as I'm clicking around in the console, that's what I'm logged in as. So you would be able to track my activity. Then I look at the actual API calls. And this is from earlier to later. And so you can see, because I've got it in time order, create snapshot, describe the attributes, and then modify snapshot attributes. Let's talk about what's going on here, because this core are the parts of this that I care about. I know this just because of experience, and you get a little time in training. But to create the snapshot, so we now know who created the snapshot. It was this IAM user called Backup Manager. Now, this is a little bit of an alarm already, because IAM users have static credentials, and AWS has published their incident response team. The last number I heard, like 66% of the breaches that their customer incident response team helps with are based on lost or exposed static credentials. That's an access key and a secret key. And in this case, I definitively know that this was done with an IAM user. Now, if you go take my CloudSlaw labs, I spent a lot of time teaching you how to not have to use IAM users or to minimize the IAM users, because they are just so risky. So this is already a red alert. This is a flag here in terms of what's going on. I'm already suspecting either a user meant to do this and they shouldn't have had an IAM user account, or it is a compromised static credentials. All right. So I have the create snapshot. Now that one itself isn't concerning. That's just making a backup. These describe calls are usually, when you see these, it's like create the snapshot and then wait to see what's going on. And that's the event name, but you can actually see the full request parameters here for what they're asking for. So this is the stuff that just happens on the back end when you request a snapshot. Then this is the big one, modify snapshot attribute, because it is create a volume permission and it's adding the all group to the snapshot attributes. Now this is a little bit of subject matter expertise, a little domain specific knowledge, but that is how you make a snapshot public, is that specific API call. So on the whole, good, bad, it's bad. Let's go back to our mnemonic. I have my resource, the current configuration state. We know it, it's public. I could have fixed it right then and there, but I'm focusing on analysis, not remediation for this video. Then the events, the API calls on that resource. I have all the API calls, and looking at those API calls in this case, I can see that most of them, there's some viewing, and then there's some sort of a tag thing here that I'm going to look at, which is interesting because I don't know. So that's probably something that happened internally. And then a lot of like describing and looking at things, which was me clicking around the console. The main ones I care about is I have this IAM user backup manager that took a snapshot and made that snapshot public. And you see my tool, like before it was finished, was trying to figure out, hey, what's going on here? What's going on here? So I have all of the events. Then there's changes. What did this look like before? What did this look like after? Now, you will likely need another tool to do this. So I'm not really going to cover that today. And in our case, it almost doesn't matter. The reason is you need a CSPM, Cloud Security Posture Management tool, or something else with inventory that tracks changes over time. You can do this with Amazon Config within AWS. Just know that config can get a little bit expensive if you're not careful. Now, in our case, it doesn't matter, because if I go back to those API calls, it didn't exist. Then it was created and it was modified. So I have the full history of it that I can read right from here. But if you have things that have been in your environment for a while and an attacker potentially got to those, that's when you're probably going to need one of these external tools or turn on config to be able to track the changes on that resource. And the changes matter. What did it look like before? What did it look like after? If somebody went in, if an attacker was actually making changes to my environment. Then, who made the triggering change or the API call? What was the trigger for this event? We know it was making it public, and we know it was that backup manager IAM user. And we're going to get back to that in just a moment here, because I want to know what were the permissions of that backup manager IAM user. This defines my identity blast radius. It is, if it are stolen credentials, how bad can that attacker hurt me? Really important to know that. Let's see where to look for that. Just do it on this page here because I don't need this anymore. Let's go to IAM. Remember, we have the name. It's right there in the query, backup manager. And we'll go in IAM. I'll go to users and I'll go to backup manager and look at the permissions. So it's right here on this screen here. Now, the good news is it's not full admin, but let's see what occurred here. And if I click on that down arrow, that shows me the policy. And in this case, it's actually pretty limited. They can change snapshot attributes. That's a permission you need just to apply a tag to a snapshot. So that's not an unusual one to see. Describe attributes, describe the volumes, create the snapshots, and describe the snapshots. So these are legit privileges for somebody who's, for example, backing things up. But you'll notice it works on any resource, and there's no conditionals or anything to restrict it from being public. Now, there's tools to keep snapshots from being public in AWS, but honestly, some of those are relatively new, like Block Public Access, and not every place I go do they have that set up properly. So this is not an unusual set of permissions. The good news is that it is restricted to creating snapshots and then modifying those attributes. So that allows you to share snapshots with other accounts. So it is a legitimate path for data exfiltration. This is a path that we know was used in real attacks. The bad news is, even though it's a little bit limited, it's anything running in this environment. So any instance, any storage volume in this environment is potentially exposed if an attacker got these credentials. So I have my permissions. The next is the entitlements of the actual resource. And in this case, I have an instance that was exposed. That instance does have a role, but it doesn't matter too much because the way that this instance was compromised, the user can't get to the role. The attacker can't get to the role. They would need other privileges to get to that role. Now, if I click on that role, it's a scary one because it's got a lot of access here. However, it doesn't matter in this particular incident because the attacker doesn't have a way to get inside. Even if they run an instance based off of that snapshot, somehow they create their own version, they're not going to get those privileges because of how IAM roles work in AWS. I am going to show you some examples later in one of my next scenarios where there are ways to actually get and compromise those. I'm not overly worried about the entitlements of the resource in this case, but like if the attacker done like a brute force and logged in, they would have all the permissions of that IAM role, and then that would be part of my blast radius also. All right, is it public? Yeah, we already know it's public. That was in the alert. What other API calls came from that IP address? There's a couple of reasons that this is what I look for. One is, and the biggest is the attacker compromising multiple identities? And if they're not smart about switching their IP address every time they switch identity, suppose they did a privilege escalation and they're bouncing between different identities in my environment, I can really narrow all of that down to just that bad IP address. I actually recently had a client have a breach. It was not in AWS, it was in Azure. And the attacker did hide behind a VPN, but they didn't change that IP address, made it a lot easier to narrow down the scope of what was occurring. And there were a bunch of different things we had to look into. And we actually followed pretty much exactly these guidelines in terms of doing the analysis, even though it wasn't in AWS. And we're able to narrow down pretty quickly the origin of that particular attack. So knowing the IP address is going to help me figure out if that attacker, well, two things. One, is that one of my IP addresses? And if so, what user has that? Is that something that I can then talk to the user and they meant to make this snapshot public, or it was just a mistake on their part? Or did they not even know this happened? Because if they don't even know that this happened, then my instant assumption is their system that they're logged in at is compromised with a remote access Trojan or something. And that attack is originating from their system, or that activity from their system, but they don't have any memory of it. I'm going to start thinking attack. The other, as I mentioned, is also looking for an attacker who's using credentials outside of my environment. So now I can kind of narrow things down a little bit, and especially if they start transitioning and pivoting into using multiple identities. How do we do this? Well, it's a query. So let's go over to the cheat sheet down here. And look, I've got queries for everything with instructions on where to get all of this data. And in this case, by the way, this includes some scripts as well, but we're going to go down to the IP address portion. So I'm going to copy this query out, and I'm going to go into one of the cool things about Athena, as you saw my little tabs before, I can add another query. Let's go ahead and add that, and then I'm going to plug in the IP address. I can pull that IP address, backup manager came from this IP address here. Copy that out, go to my query, copy that IP address in, paste, and then I also am going to need my from. It has to be this table. Copy out my table and paste it in there, and let's run our query. And we're going to see probably a whole lot of stuff. 381, because I'm running this on my home system that's routed through a VPN. So the attacks and my defense of me clicking around the console are all going to come from the same location. And you can see that right here. Now, in a real attack, I'd be a little nervous about this because I have attack activity as well as legitimate activity. So I started looking to see if somebody hacked my Mac. I know it's a Mac because it says so right there in the user agent field. Other things we look for, though, are changes in the user agent field. And this is another good indicator of potential attacker activity. Like if me, the main user, always does everything from my web browser, then all of a sudden I'm making API calls using Bodo3, which is Python, then that's, to me, indicative of a scripted attack that's running somehow. So I now have a sense of my IP address, and in our situation, now I'm telling you it doesn't matter because it was from my system, but if this was actually in a real situation, I'd be very nervous with seeing both legitimate and illegitimate activity coming from that same IP address. Going back to our analysis sheet, the caller. So all the other API calls from that calling identity, which is backup manager. And we've got another query for that one, which is the caller query down here. Now there's a couple of different ones. One is if it's like an IAM role. One is if it's an access key. The one I'm going to use, since we have a username, is I'm going to use the username query. So I've got all three listed here to kind of guide you through this process. So let's add another query here. We'll paste it in. I need to add my table name again, so I know where I'm selecting from. And the name here is backup manager, just like we saw in our earlier query. Let's go do a run. Now you can always change what these top parts are. You notice I've been bouncing around different ones. You can look at what was the AP. It just depends on what you're doing. And if you want to keep it simple, you could just kind of narrow it down a little bit, but I have just defaults I tend to use, which is what you see here. So here's all the API activity from this IAM user. And it's any single API call where that username appears, all from the same IP address. And the actual event names describe volumes, create snapshots, describe snapshots, modify snapshot attributes. This is helping me narrow down the scope of my incident. They only exfiltrated data from that one instance because I only see this pattern once with that given identity. So unless they pivoted to another identity with different privileges, I'm already figuring out the scope of this particular incident. Going back to our mnemonic, and I have looked for indications of a pivot. This case, I don't have any indications of a pivot. Now, if I saw user agent changes and different IAM calls from different users, and I am going to show you examples of what a pivot would look like. But in this case, it's pretty narrow. They didn't have permissions for anything where they could have pivoted. The only thing maybe would be that I would look for is, and this comes into the next step, is if I had any stored credentials in that instance. The attacker now has those. So if there were any database passwords, any other IAM user credentials, those are exposed. That's how the attacker could pivot. And I'm going to figure that out with my last step, which is the actual forensics on the instance, or going deeper into logs. Let's take a step back. I want to talk about what I've shown you here, and I'm going to walk through a little bit step by step because I know I did move pretty quickly, and give you the bigger perspective, and then describe all of this particular incident and where my head would be if I was seeing this for real, as opposed to seeing it in our, kind of contrived way of doing things here. I like the recipe picks because it gives me most of the information I need very quickly. That resource and knowing what the configuration of that is, knowing all the API calls on it, and then knowing what changes. So the REC portions of that. What did it look like before? What did it look like afterwards? And in our case, we have a snapshot. That snapshot was taken from the storage volume. That was the boot volume of an instance that was in our development auto-scaling group for web servers. So not horrific. That came in from prod. And it's kind of funny, the last time when I was doing my prep work, my automated script pulled from prod and not dev. So that one was a little more concerning. But I still am a little worried here. Then, who made the API call? Well, it was an IAM user. And right now, I don't know how those credentials leaked. That would be the next part of the process that goes outside of just the cloud incident analysis piece. I'm showing you everything from the cloud management plane. There's other pieces. Real world example, when my client got breached, they narrowed it down pretty quickly to the actual system. And then we're able to run forensics on that system to figure out how the attackers, the adversaries, were able to get onto that system. That's a critical, important piece of the process that we're not covering here. And they handed that off. Once they figured out what the origin came from, that got handed off to a forensics firm to go ahead and do the analysis around that. Then we have, what is the blast radius? So I'm figuring that out pretty quickly. The blast radius based on what was compromised in terms of the IAM user or role or whatever credentials were compromised that made that change in the cloud, as well as the blast radius of, well, if they logged into an instance or they got into some other resource, a Lambda function, a container, what other damage could they do? What were the permissions of the thing that they compromised? Both of those are going to determine that identity, that IAM blast radius. Why am I not talking about network blast radius? You know what? That's at the bottom. That's when I start doing the forensics piece, and then I would hunt around the network pieces. In cloud, my priority is keeping the attackers out of my management plane. That's the cloud native portions of these breaches, because that's like giving them full admin mode to my data center, potentially. So I want to clean out the management plane first, then I'm going to worry about the network and the other resources. I'm going to figure out stuff public very quickly. That matters or doesn't matter. What other API calls came from that IP address? That's going to help me figure out, was it a compromised user? Was it exposed credentials or some mix between them? Not always informative, but frequently it is. What other API calls? What other things that identity tried to do? And then I'm going to look for any indications of a pivot. After all of that's done, then I'll dig into the network logs, then I'll go into my instance forensics. And that is recipe picks. It's a really quick way to run through and figure out what's going on in an incident and get most of the information you need. Now, once you've gone through this, then there is the longer tail part of the process for incident response. But I really like the mnemonic, did a cool little infographic so you can have that available, because you know what? Even I don't always remember it, and I wrote it if I haven't used it for a while. Unfortunately, that's true for my paramedic and my aviation stuff as well. You forget a lot of them, but it's pretty easy to refresh that memory. Hope you guys found this useful. If you want to get more information around cloud incident response, drop me a line. We don't teach that class on a regular schedule. We do teach it every now and then. And if you just want to learn more about cloud security in general, just sign up for CloudSlaw. I just finished our first year. That is literally 54 labs that have been complete, coming out on a weekly basis. Everything in order, teaches you how to build a large scale enterprise in a very secure way. Thanks for your time and have a great week.